Whenever I need anything for clamping on the mill or lathe or whatever, I use this a studding you can get from B&Q. It's just very kind of steel, plated steel. Perfect because you can just chop it up to whatever length you want, and if it really came to it you could discard it afterwards. So, and I make T-nuts. I don't normally buy T-nuts, I make them. Any scrap that's left, these in particular were some I made from scrap aluminium, and that it happens to be M8. M8 is the size of the bolts that went through here, so I can mount it on the mill quite easily using M8 studding. So that's what I'm going to do. I'm going to chop some lengths off so I can actually bolt this to the lathe. There's a couple of ways to mount this on the mill, and normally I would have put it on a bit of sacrificial sort of ply or something, but for the sake of quickness, I'm just going to bolt it to the main table, line it up in the X direction, drill the holes. In fact, maybe just center drill the holes and drill them through as a separate operation. Take it off the table because obviously I don't want to go through into the table. Okay, right. I've zoomed in. We could have used a dial gauge on the spindle to line this edge up with the X direction of the table, but I decided to use a laser, the laser center finder. So I've zoomed in so you can actually hopefully see the laser light. You can adjust it for size. That's about as large as it gets, and for the sake of argument, you take it to the edge. I usually get it so I've got a part of the beam equal brightness on the top edge as it is in where it's going down onto the lathe bed where you can't see. I can adjust it so each dot is the same brightness. Then and I move the table along to get the same. Now it's totally off the. Now I'm back on. I'm equal brightness top and bottom there. And equal brightness top and bottom there. I'll show you what I'm trying to explain. I'll turn the light off. You see the beam at the top and the beam at the bottom, equal brightness. Now if I move the table, the bottom beam dims, the top beam, where it hits the top of the plate, is brighter. Turn it back again, and now it's all at the bottom. So I'll go in between to equal, roughly equal brightness, which I would say is there, and that's my edge. How accurate is it? Well, I've actually I'll do a little video on it, but I've actually tested this with the other various types of edge finder, and this is on par. They're about the same accuracy. None of them's absolutely perfection, and most of them are quite reasonably good. But well, anyway, do that another day. The problem is this: is batteries, of course, and batteries don't last long when they're driving laser lights. What I'll actually do now is tighten up the nuts. What I need to do next is find the center of this plate, give or take a thou. You know, it's not super accuracy required, but we want to get as close as possible. We could use a dial gauge, but in this particular instance I'm going to use one of these newfangled coaxial indicators. Right, for that we're going to have to drop the table a bit. Oh. And hopefully this might do a trick. I can... Let's see. Let's see if I can get it short. I can adjust it half the distance. Right, now we turn it back up, which is the hard side here, is it there? It's here. The low side, so we turn it to 0. Now we slow this up. I was finding it hard to get the camera to focus on the on this dial, so I'm going to just run through it again. With I've moved the camera back so it will actually focus on the zoom. I'm going to clear. Well, it doesn't really matter, does it? First of all, I'm going to turn. Let's set this up. Let's see what we got here. So the idea. Let's just whack a bit of oil in again. Whack a bit of oil in where the probe is rotating in. The idea is to turn the X and Y handles axis until we get a 0 reading. I'm doing the Y now. About the best I can get on Y, so I do the Z. It's getting worse. It's about the best on Z. Go back to Y. Said. Right, that ain't bad, is it? I'll call that 0. Okay, we're ready. I've put the I've round the table up and raised the table, fitted a center drill, ready to drill out the plate. As explained previously, I've been in the CAD, and as you can see, that's tilting the motor at 15 degrees. I can clear the bolt heads, the original bolt heads on the spacers, so I can drill the new holes. Being concentric around the center, you notice the repeating measurements here. I got 43.66, 21.77, 43.66, 21.77, 21.77, 21.77, and 43.66. There's a kind of refreshing to know that if it's concentric, you're going to have the repeated numbers. Well, we can get ahead with that, and I'll leave that here as a reference, and we can actually start machining. So I'll zoom in. Actually, I'll get close to the work. Okay, ready to matter what lengths you go to measuring things, it's always worth just doing a simple cross check with the motor, and it looks pretty good to me. Okay, so what I can do now is run some drills through. This is not a normal way I would go about things, but it's slightly quicker. I can drill through like that, you see, no problem. Okay, we're all set. Probably not the correct way to do this, but it's certainly the quickest. I'll use a bit of, what I basically do is make sure it goes down between the opening in the vise. That's perfect. I'm happy with that. Now we just take these holes through as pilot holes. The problem I find with mills is that they you don't get no feedback. You don't get no how much pressure you're applying. It either cuts or it breaks. The only thing I don't like about